right, guys, so last class, what did we do? We got the factoryio talking to the Siemens TIA Portal, and we had a basic 2 and 3 wire control, and then we brought in the HMI. So the next thing we have to look at is the timers. So we're going to set up a circuit like this, where we hit the start button on the control panel on factoryio, and once we do that, then it turns on the timer, and then we'll see the value increment on the digital display here. So if we hit the start here, then it will increment up. And with this guy, this is a non-delay timer, so it takes some time to change state. And you can see that as soon as the Q value goes true, then I've got a light that turns on here. If I hit the stop at any point, then it turns off the timer. Okay, so let's take a step back. Let me show you how I created this program and the different settings that we had for last week in order for this program, the TIA, to talk to the factoryio. I'll show you some changes that we've made within the factoryio to make sure that everything is working together. So let's take a look at our TIA portal first. So if you are working on this in the lab, then where's my USB? Then on your desktop, you have this folder, Advanced Instrumentation. So you're opening this folder here, and in order to open up that Siemens PLC program, like you may have saved it to the desktop, so you can use your save program, or if you've lost that one, then open this one up. So generic PLC and HMI and factoryio program. So this one, once you open it up, I want you to save it as a different name, because I want these programs to be here in case you screw something up. You can always go back to these programs that work. I know they work because I've tried them out. And I don't want you to save to this file folder, Advanced Instrumentation. If I make any changes within this folder, I basically wipe out the folder off of the computer, and I put a brand new Advanced Instrumentation on there with all my gorgeous material on there. But in doing so, if you have saved to this file, then your program will vaporize and disappear. So save to the desktop. If you just want to do things simple, then use my program. So you're going to open up this generic program, and you double click on this guy, and it will open up a base PLC program. Okay, so let's open up this guy. Let's go offline. Okay, let's go back to the portal view. So when you open up your program, so I'm just going slow because this is what our 4th week of doing PLCs. So each week we're just doing a little bit more than we did the week before, but it's been a week since we last talked, so I'm just going through all the steps. So once you open up your program, then you're going to go to Project View. Once you're in Project View, then you will have a blank slate. There won't be anything in your OB1. You might not even be able to get to your OB1. So in order to get there, you need to open up this project tree. So you're going to expand this one right here by hitting this triangle. When you open that up, then if you want to look a little bit more and see everything, you can move that to the side. So yours is going to be set up like this, with your PLC and the HMI that we had set up from before. If I want to see my program, I hit this triangle right here. I move down to Program Blocks. I open up Program Blocks. And if I double click on Main OB1, then it opens up this window right here. For you guys, this will be a blank slate. Okay, the changes that we made last week within this program, because this is the one that talks between the PLC and the factoryio. So let's look at the changes there. So let's go to Device Configuration. So we're double clicking on this guy. You'll notice that another tab opens up on the bottom here, and in 2 seconds, the actual PLC will come up. So there's our PLC, there's our analog card, and so if we want to make this just a touch bigger, we'll go to 200%. And what I want to do is right-click on the PLC, and then go to Properties. Once you do that, then this should come up. Again, if that doesn't come up, if it's hidden below, then just hover over here till you see this line, see that? Hold down your mouse button and bring it up so you can see the properties of the PLC. Okay, again, I right-clicked on this portion right here, right? That's my PLC right there. Don't right-click on this. This is an additional analog card, and this is an additional analog card over here. So I'm right-clicking on the S7-1200, and then I'm going to Properties, and then it brings up this guy, and if I want to see a little bit more, I bring this up, and I'm good to go. Okay, so first thing is that every PLC in the lab has 192.168.0.10 as the address for the PLC. So make sure that you have disconnected from the Ethernet switch and you're going from the computer into your box with the PLC, and that way you're not talking to your friend's PLC across the room. We can change this IP address later on, but for beginners, it's much easier if we can just grab any box with any PLC and download our program. Each of the boxes will already have this IP address already in there. That's the first step. Okay, next step is our I/O addresses. So below here, so you have digital inputs, digital outputs, I/O addresses. Click on this guy, and you'll notice that we have offset our physical inputs by 10. That is so that our physical inputs, which are at a 0 because we don't have any signals going in, they don't supersede, I would say trump, but I'm not using that word anymore. They would supersede any value that's in the PLC program. So we have to offset the value by 10, and that way our physical inputs are not going to interfere with our inputs within the factoryio. Okay, last thing we needed to do was, aside from the Ethernet address and the I/O addresses, we came down to protection and security. So we clicked on this guy. We gave it full access, so no protection whatsoever, and we went down, and I have no idea what this means, but we clicked on this one, permit access with POT, GET communication with remote partners. So that allows us to talk to the factoryio. Okay, once those guys are there, then we're coming back to our main OB today. Okay, I can go back to my main OB here, or I can click on my main OB right here. So let me just make this a little bit bigger so you can see. Okay, so I want you to start off with a 3-wire control. So a stop, a start, similar to the previous labs that we did, right? These are inputs. You'll notice that these are not offset by 10. And the reason why they're not offset by 10 is because these numbers right here have to match with the factoryio. So if I go to my factoryio and go to File and Drivers, then you'll notice that my stop is addressed to input 0.0, and my start is input 0.1. So that corresponds to this stop and this start. Okay, if I go back again to, what are you doing, Pete? File, Drivers, then my reset is on input 0.2. So if I need to make use of my reset, I'm going to use input 0.2. So that's why I had to offset my physical real world inputs by 10 so that they didn't mess up any of these values. Okay, then I have the output Q0.0, and I have labeled that Timer.Q. And then you may have to drag this down. So this may not be there. For some reason, I keep changing this and then saving it, but it's not saving properly. So you may have to grab the digital display and drag it down to QW100. And you'll notice that it's an integer value. Okay, so the value for the digital display is being held in a word, and it's an integer value going to that display. Okay, once you're there, you can then quickly go to configuration. Make sure that the IP address 192.168.0.10 matches with your PLC program. And then once you actually download the program to the PLC, then you can hit connect. So I don't have anything here. Let's say I've already downloaded my program to the PLC. I can hit connect, and then I should see a green check mark. If you try to connect without having the PLC program in the actual PLC, then this will not work. So our next step is to download our PLC. But before we do that, we need to do one more thing. So this digital display, again, I keep changing this and saving it to the image, but for some reason it's not saving properly. I want you to right-click on this guy. Is it right-click? Here, sorry, I have to stop this. So you're not playing, you're hitting stop. I believe it's a right-click. Yeah, so right-click on the digital display, go down to configuration, and change it. Yours is most likely going to be set from 0 to 10, so 0 to 10 volts. But we're looking at an integer value, so switch this to integer value. Okay, one more time, I right-click on the digital display, go down to configuration, and I change it to integer. Okay, then it will be able to show my, in this case, 1 through 5. Okay, Once you're done that, then we're going back to our TIA portal, and we're going to drop in a 3-wire. So in this program right here, I've got an input, a physical input that matches with my factoryio for my stop, input 0.0. My start push button on factoryio is input 0.1, and I'm just going there to a memory bit. So remember, this is just a bit in the memory, and all it does is it turns on another line in my program down here. Doesn't do anything else other than that. Okay, the 3-wire control is that when this guy is a 1, this one's looking for a 1, and so this provides logic continuity. So when I let go of the start push button, then it keeps that M0.0 true. If that guy's true, then all of a sudden it will turn on my timer. So the second line I want you to do is to drop in a timer here. So these guys are easy. You're just dragging and dropping down from your favorites full tab right here. But in order to find this timer, then you open up your instructions. So see this arrow right here, or this triangle? I'm going to expand here. I'm going to go to instructions, down to timers, and it looks like we have a pulse timer, an on delay, an off delay, and a retentive timer. So we're going to start off with an on delay timer. We're going to grab this, drag it over, and drop it down. Okay. Once it's dropped down, then it'll ask you to hit OK. You're going to do an automatic rather than a manual. And I just kept it as IEC timer 0. You can change the name if you wish. Okay. Once that's in there, then I want you to put in a preset time of 5 seconds. So remember that the standard is that when you put in a value, it's in milliseconds. So you're going to have to put 5s, or you're going to have to put 5,000 as the value, right? So if I put in 5, then it's going to say 5 milliseconds. Well, that's no good. I want 5,000. And at that point, it changes to 5 seconds. Okay? We're going to leave the elapsed time the same, like not connect anything to it. But I want you to have an output here, because I want to turn on a light when this guy is true. So when the timer Q is true, then I'm going to turn on this output, Q0.0. And I have tied the Q0.0 into this guy right here. So that guy is going to be my light right there. So Q0.0 is going to be going to my light, which I've labeled Timer.Q. Okay, so that's this guy right here. Okay, if we go back, that's this guy right here. Okay, if you want to rename these guys, how do you rename those guys? I'll leave it for now. This is an important point. For this scene in factoryio, you don't have to create this one. This one's also going to be in your advanced instrumentation folder under factoryio scenes. If you double click on this guy, then this is the timer tutorial that you're going to open up. So it will open up this image for you. And you just have to make those small changes that we saw before. When I remember, I will tell you in class how to change those names. I can't remember. I think it's like edit. I can't remember. I think you dock all your tags. And then once the tags are docked, yes, once the tags are docked, then you can change the label on there. So in order to change any of these labels, so they'll just have generic labels, or this one might not be labeled Timer.Q. So again, I went to View, dock all the tags, and then I can double click on each one, and I can change the name of that light if I need to. Okay, so I'm going to go here, I'm going to clear all my dock tags. So in our program here, we have our memory bit turning on our on delay timer. We're going to use 5 seconds, and we're going to have that going to an output Q0.0. Okay, in order to send that value to the digital display, I got to do 2 other things. So what I'm going to do is I'm going to divide the value, because these are in milliseconds, right? So this is going to increment from 0 to 1,000 to 2,000 to 3,000 to 4,000 to 5,000 milliseconds. So I just wanted on my digital display, I just wanted to display 1, 2, 3, 4, you got it, 5. Okay, so what I want to do is I want to divide my IAC timer. So what I did here is I went to my my timer, and then for the timer I have the ability to look at my elapsed time and my preset time. So I'm looking at my elapsed time, and I'm just dividing it by 1,000. So my input 1 is my IEC timer 0.et, and I'm dividing it by 1,000, and I'm going to have that go out as a memory word. Okay, so I'm going to have one word holding all those values, and I just relabeled it as counter value. You'll notice that down here I have MW100 and %M1 MW100 here. So these guys are identical. This value will go into here. So I've used division. So that, where would you find that? That was probably under math functions. So I'm grabbing this division, dragging and dropping into here. And then what I'm going to do is I'm going to move that value. So I want to move it from the memory to the real world. So I want to move this word to this word right here. So I'm moving the value of %MW100 to %QW100. QW100 is matching with my factoryio in my drivers. And we found, see, look at that. It's so weird how that keeps disappearing. So that digital display is going down to QW100. Okay, hopefully that's all fairly clear. Let's take a look one more time at our program now. Where did I get that? Wait a minute, going a little bit too fast. Where did I get that move function? That guy was right here under move operations. I opened this up, I grabbed a move, and holding the mouse button down, I dragged and dropped it onto the page. And I just labeled this one %MW100, and I labeled this one %QW100. So I don't have a preset program for you to just open up and download, because I want you to go through the motions of finding these guys, dragging them in, making mistakes, seeing that it doesn't compile properly, and trying to find where your mistakes are. Okay, but the actual program is really simple. We have a 3-wire control, a stop, a start, and a holding contact. That holding contact is tied into this memory bit. That memory bit is then turning on a timer, an on-delay timer in this case, with the preset of 5 seconds or 5,000 milliseconds. And on the Q, we have an output with Q0.0 that turns on a light on our display. So that's going to turn on this bad boy right here. Okay, then below that, I have one math function, a division function, a double integer here, where it's taking the IEC timer elapsed time, the ET value, dividing it by 1,000, and then punching that out in a word, a memory word, %MW100. That %MW100 is going into a move function, and I'm simply moving it from the virtual world to the real world, MW100, moving over to QW100. Okay, once you've done that, we've done a number of different changes, right? So first thing is, click on the screen here and go up and compile your program and see if you've messed anything up. Okay, cool. I've got 0 errors and 0 warnings. So that means that my software is cool. I haven't made any mistakes in the software. Okay, I made some hardware changes though. So remember, you have no idea what the previous person did on this PLC. So we need to drop in both the hardware and the software changes onto our PLC. So if I download this, I'm only going to download the software, and I'm not going to be able to talk to my factoryio. I have to download my hardware changes, like that offset of 10 for the inputs and the protection and everything, and I have to download my software for my program. So I'm coming over to PLC, I'm right-clicking on this bad boy, I go down to here, I've already compiled it, I'm going to go download, and I go download my hardware and my software changes. Okay, this is going to rock through because I already have my program there, but it will ask you for, like, remember the steps are that you're choosing Profinet, and then you do the search, and it finds the PLC, and it finds the HMI, and it may need to do another IP address for the PLC, like it goes to 0.241. You just hit OK, and then remember that you may need to do manual configurations, right? There's a difference between what the PLC has and what you're dropping in. Mine's identical, right? Hardware not be loaded because the online status is everything's like exactly the same, right? So, but just keep hitting OK, 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 then hit load. That'll drop your program onto your PLC, and then hit finish. Okay, 0 errors, 0 warnings. Beautiful. Okay, now that everything's there, I'm going to move everything to the side. I'm going to drop this guy down to maybe 100%, and I'm going to go here and hit the Corey. You guys don't seem to know who Corey Hart is, but the Corey Hart sunglasses for the monitoring on and off. So click on this guy right here. That will bring us online. So if we had this open, green lights all the way across, green for logic continuity, gorgeous. Okay, now I'm good. Now I'm going to float this guy right here. So I floated the image, then grab this guy and then bring it over to the center of the screen, bring it over to the side, snap her over, and then it will be good to go. Then open up your factoryio. Again, if it's not there, you can bring it over to the side, snap her, and then it will take up the rest of the screen. And I want the factoryio to be a little bit larger, so I want this guy over top of my TIA portal. Cool. Okay. Before I do that, let's make this large. I need to go to File, Drivers, and at this point, you have now dropped in your PLC program, so now you can hit Connect. Now you see the green check mark, and you are ready to rock and roll. Go back over here, hit Play. Okay, then float this guy down, bring it up so that both of them are on the screen. And now, let's see if I hit this stop push button, whether it changes. Very nice, it changes the value on the screen here. So when I hit the stop, you can see that it stops or changes the state of that examine if closed right here. Okay, so when I hit the start, this is an on-delay timer. So this is going to take, let's see, 5 seconds to increment. So you'll see this value increment up. And after 5 seconds, then the timer will change state. When it changes state, then my Timer.Q will be true, and this light will turn on. Okay, I'm going to drop down a little bit so you can see the division and the move as well. So hopefully we will see this guy mimicking the value that's up here. Okay, so we'll hit the start. Once we hit the start, our memory bit will go true, and that will make our timer turn on. Okay, so this one should increment up by 5, 2, 3, 4, 5. This guy goes true, so this guy goes true. Beautiful, and you can see that this value is just moving to here. Gorgeous. Okay, so if you had any issues there, then go back to your program or go back to your factoryio, make those changes so that everything's coming in nicely. But let's take a look one more time at this guy. I'm going to hit the stop. Excuse me. Okay, as soon as I hit the stop, then this is no longer true, and the Timer.Q is false. I'm going to hit the start, and I'm going to hit the stop halfway through. So it's incrementing up. If I hit the stop, then this guy never went true. The only way that this guy goes true is if your preset time and your elapsed time are the same. So it has to increment up to 5, then it's true. Cool. As soon as I hit the stop, this is no longer true, and you can see that the elapsed time goes right back to 0. So this one does not retain the value. Okay, so that's an on-delay timer where you send the signal in, and it takes a little bit of time to change state. Excellent. Now we can look at an off-delay timer. So watch this. This is awesome. Offline. My tickle in my throat, sorry. And I want to change this to an off delay, so I'm going to click on this bad boy. You could just make out there is a little orange triangle right there. And when I hover over that guy, I can change this from an on delay to an off delay timer. I've made a software change, so I'm now going to download to my PLC. I'm going to overwrite my OB1. I don't have to do anything with the hardware because the hardware was already set. I go back online, and now I can use this same guy to check out an off-delay timer. Okay, same circuit. If I hit the start, this is an off-delay timer. So the off-delay timer has to be energized and then de-energized. So I'm going to hit the start. This will go true, and you'll see that the timer changes state right away. Okay, so that output changes state right away. My elapsed time is still 0 because an off-delay timer has to be energized and then de-energized. So when I hit the stop button, then this will no longer be true. So we have now put a positive pulse in here. Now we're going to take that pulse away. Then the timer will start to time out. This is still true until these guys are the same right at that point, and now my Timer.Q goes off. So with an off delay timer, with you hit the start, it changes the state of the output right away, but I have to take away the input to the timer. Once I take away the input to the timer, then it starts to time out. So this is like an exhaust fan. You keep an exhaust fan on for another 5 seconds after the machine has turned off. Hit the stop, now it times out for 5. Once these two values are the same, then all of a sudden this guy turns off. Beautiful. Excellent. Hopefully that helps you with an off delay timer. Okay, then I want you to change this to the next guy. So we're going to go offline. Remember that in our instructions we had, let's look at our timers here. We had an on delay, an off delay, a retentive, and a pulse timer. Okay, the next one we're going to look at is a pulse timer. The pulse timer is cool in that it just needs a quick pulse, and then it will change state. So watch this. We're going to change this to a pulse timer. Okay, once we've done that, we've made a software change, so I'm now going to download that. I don't need to compile because all I've done is just change the timer. Zero errors, zero warnings, beautiful. Go online. And now we can use this same program now to look at a pulse timer. Okay, a pulse timer just needs a quick little pulse, so I'm going to hit the start, and I'm going to release the start, or no, that's not going to work. I'm going to need a little pulse. So in order to have this pulse going on and off, I'm going to have to hit the start and then hit the stop right away. So watch this. I'm going to hit the start. I hit the stop. This is no longer true, but that little pulse came through, and now it times out. So what did that look like? Did that look like an on delay or an off delay timer? Let's take a look at it again. Pulse comes in. Pulse is gone. Takes some time and then changes state there. Is that an on delay or an off delay? Looks like it's like an off delay timer, right? Because it has a little pulse that comes through, right? And as soon as the pulse comes in, then it changes the state of the output. And then once the elapsed time and the preset time are the same, then it changes back and reverts back to the rest state there. So little pulse coming in, so I'm hitting the start, I'm immediately hitting the stop. That way this will be true. And that, I mean, I'm taking several, like at least a second to chew that, right? But this could be like a millisecond input into this timer here. Little pulse. All it needs is the rise from a 0 to a 1, and then that positive pulse will turn the timer on. So positive pulse in, that thing is gone, whoops, and it increments up. Beautiful. Let me just zoom in one more time. We'll show it one more time. So this is where you have just one pulse come through, and you need to kind of make use of an off delay timer here. So pulse comes in, pulse is gone, keeps incrementing up until the two values are the same, and then the timer output turns off. Okay, so most of the time you'll be using an on delay or an off delay. This is a cool little timer, a pulse timer that you can make use of as well. Okay, let's go offline. There is one more timer to look at. So none of these guys have been able to retain a value. So we need this guy, the on delay with the retentive timer. So it's going to mimic an on delay timer, but it's going to retain the value. I need a reset push button here though. So let's go back to the factoryio. Let's make this guy bigger. And let's go to File, Drivers. And it looks like my reset is tied into input 0.2. Okay. Input 0.2. Okay, so let's go back to this guy. I need to drop in an input into my reset there. So I'm going to drag and drop into my reset there. I'm going to label this guy % input 0.2. Okay, I've already labeled this as my reset push button. So I'm good to go. I'm going to now click on the screen. Then I'm going to compile it just to make sure that everything's cool. All right, everything's good. I've made a software change, so I'm now going to download that to my PLC. overwrite my OB1. Beautiful. Okay, and go online. Very nice. Okay, so we'll take a look at this guy. Remember that these guys are all the same throughout. The 3-wire and the division and the move have been the same, and all we've been doing is literally clicking on the timer and changing it to an off delay, a pulse, or now a retentive timer now. Okay, so this one should hold the value. So this one is an on delay timer, so it's going to take some time to change state. The only time that it's going to change state right here is if the preset time and the elapsed time are the same. I've made a preset time of 5 seconds, so the elapsed time up here has to be at 5 seconds before this guy is going to change state. Okay, so I'll hit the start, and again, it goes up to 5. Once it gets to 5, then it changes the state of the timer. Okay, if I hit the stop, ooh, that's cool, then the value stays at 5, so it retains the value. Remember that if we hit the stop, and this, easy now, and this was no longer true, then we lost the value. This reverted back to 0 milliseconds, right? But right now we're stuck at the 5 seconds. So I'm going to hit the reset push button. This is tied in with this guy right here. So if I hit the reset, then it should, very nice, bring it back to 0. So now this guy and this guy are exactly the same. Cool. Okay, so let's hit the start, and let's stop it at like 3 seconds and see what happens. Hit the start, 1, 2, 3. We'll hit the stop, so this is no longer true. And look at that, we stopped at 3.489, right? So this is only showing us the integer value of 3. It's not showing us the milliseconds there. But we stop there and it retains the value. Okay, so we can see that the value is at 3 right now. I'm going to hit the start, hit the stop again, and I go up to 4 seconds. This is not true yet because I need the elapsed time and the preset time to be the same. So as soon as it gets to 5, then the timer output changes. Beautiful. So if I hit the stop, that value is still there. I have to hit the reset. This will be true, and it will bring this back to a 0. Cool. So a TONR is able to increment up, just like we had with the on delay, but it retains the value in the memory here. Okay, and that value right there is going to an MW100, that's going to QW100 and being displayed right here. So if I start again and stop, then it retains this value in there. If I hit the reset, it goes back to 0, and it's an on delay timer, so it will take some time to change state. So I have to increment up all the way to 5, and once it gets to 5 and the preset and the accumulated are the same, then the Timer.Q output turns on. Beautiful. All right, guys, so we've gone through all the different timers with this simple project here. Next week, we're going to bring everything together. So we're going to go back to doing our conveyor project, and we're going to make use of this timer. Like, we're going to have some flashing lights. So we want when we hit the start, we don't want the conveyor to turn on for a couple seconds until a flashing light has gone off to tell the operator that the conveyor is going to turn on. So you have a week between now and the time that I'm going to present that information. So you may want to come and see me and get the handout, and that will tell you exactly the parameters of what we're going to do for next week. And then you can think about it and come into class when the lab is open, but there's no classes running. And you can work away at it so that next week during lab, you can just rock through it, or you have a really good understanding, you get it done, and then you can help your partner to understand it. But you really need to understand all the different types of timers before we move on. So make sure that you create this project, have it talking to the factoryio, go through the on delay, the off delay, the pulse timer, and now the retentive timer. Make sure you're cool with all those guys before we move on. Make sure you understand how to do the division and the move function, and ask me as many questions as you can going through. All right, guys, thanks for your patience. Hopefully that cleared everything up, and hopefully we'll build on this to build a pretty cool project next week. All right, we'll see you in the next video. Thanks very much.